our symposium is called Children's Math Engagement, Exploring Cognitive, Contextual, and Family Influences. So understanding influences on math engagement and math ability is important. And so our symposium has 4 talks that will examine factors that influence children's engagement in math, as well as the impact of engagement in math at home on children's math abilities. So first, I will present on parent and child math talk and the role of spontaneous focus on number and math ability. Then second, Marjorie Schaeffer will present on the role of parents and teachers' math anxiety on children's math achievement. Third, Dawn Short will present on how attainment is affected by math attitudes in children, teachers, and caregivers. And finally, Andy Ribner will present on the effects of an early math intervention in parent-child math activity engagement. And we plan to have time for questions after each talk, as well as at the end if there's time. And Geetha and I will be monitoring the chat for questions as well. So I guess to start with my talk, so today I'll be presenting work with Richard Prather and Geetha Ramani on parent-child math talk, spontaneous focus on number and math ability. So children's engagement in math is important for their math learning and development. And one way that children engage in math is through talk with parents about numbers and numerical and mathematical concepts. And we know that parent and child math talk relates to children's early math development. However, parent and child use of math talk varies widely. And because early math knowledge is predictive of later achievement, understanding what factors contribute to and influence variation in parent-child math talk has implications for children's math development. So one factor that may account for some variability in parent-child math talk is the ability that parents and children have to perceive number in their surrounding environment. And spontaneous focus on number, or SFON, is the tendency that a person has to notice number and numerical aspects of their environment when no cues are specifically directing their attention to number. And SFON is known to relate to math ability in childhood, and it might be especially important for math talk because being more aware of numerical aspects of the environment may increase talk about number. For example, many activities that like playing and reading and cooking that lend themselves well to number talk are not specifically focused on math concepts or specifically designed to lead to a math interaction. However, they can provide many opportunities for math talk if parents and children notice the numerical and mathematical aspects of them. So the goal of the current study was to examine factors that might influence math talk, including parent and child SFON and parent and child math ability. And data were collected from 78 children ages 4 to 6 years old and their parent. And parents and children completed one lab visit about 2 hours long, and it included a 15-minute parent-child play interaction, measures of parent and child SFON, and measures of parent and child math ability. So parents and children completed a 15-minute play interaction consisting of a modified 3 bags task. And they were shown 3 boxes with play materials and asked to play with the materials as they would at home. And they were told they could use the materials for any amount of time they would like, as long as they open each box and use them in order. So the first box had a wordless picture book called Hank Finds an Egg. The second box had a toy cash register with play money and a shopping basket with plastic foods to play with. And the third box had a toy balance scale with colorful blocks and bears. And we chose these materials because they have the potential to elicit math talk from both parents and children, but they don't require mathematical talk for use in play or for successful completion of the play tasks. And parents and children also each individually completed 2 measures of SFON, and the same measures were used for parents and for children. So the first was a picture description task where an experimenter showed them a picture and asked them to describe what they could see in the picture. And SFON was measured as the number of number words they used in their descriptions. And the second was a matching task, where they were shown an image and 4 options below it and asked to choose which of the options was the best match. And options varied on number, shape, color, pattern, or location, and SPAN was measured as the proportion of times that the number option was chosen as the best match. And finally, to measure math ability, parents and children each separately completed the applied problems and calculation subtest of the Woodcock-Johnson 4. Parent-child interactions were transcribed and coded to examine parent and child use of math talk. And this video has a short example of how a parent and child might use these materials and initiate math talk during play.
Again, how many carrots? 2 carrots.
So math talk was measured in multiple ways. So first we looked at the number of number words used, and we extracted these from the transcripts, including the numbers 0 to 100, as well as references to larger numbers, including hundreds, thousands, or millions. And second, we also coded parent and child use of math talk to examine the quality and quantity of talk that parents and children used. So the coding categories included counting, which included saying a count list, prompting counting, or discussing counting as a strategy. Numeral identification, which included identifying written numerals. Cardinal values, which included labeling numbers in a set or asking about the quantity in a set. Arithmetic, which included addition, subtraction, multiplication, and division. Magnitude comparison, which included comparing quantities or making statements about relative quantity. And contextual use of numbers, which included using number words in context, such as referring to prices, money, times, dates, or ages. So first I'll describe parent and child math talk. So overall, we saw large variability in the amount of math talk that children and parents used during play. Children used on average 34 math utterances, ranging from 5 to 78, which represented a wide range of proportions of their math to total talk during the interaction. And parents use on average 55 math utterances, ranging from 6 to 157, which represented a similar range of proportions of math to total talk. And in terms of the types of math talk that we coded, we found that the majority of math talk for parents and for children was related to contextual use of numbers and cardinal values. So first we looked at SPAN and math talk, and we ran separate multiple linear regressions predicting math talk from each SPAN measure for parents and for children, controlling for child math ability. And we found that SPAN was not a significant predictor of math talk for parents or for children. And next we're interested in examining SPAN and math ability. So we examined correlations of each measure of SPAN and math ability for parents and children. And we found that SPAN as measured, SPAN as measured by the picture task related to math ability for children and for parents. And finally, we were interested in how math ability related to math talk. So to examine this, we first created composites of math talk, including foundational talk, which included counting and numeral identification, and advanced talk, including cardinal values, arithmetic, and magnitude comparison, and contextual use of numbers remained its own category. And we looked at correlations of these composites with parent and child math ability. And we see that child math ability significantly relates to their own and their parents' talk about contextual use of numbers, and parent math ability relates to their own and their child's use of advanced math talk. So overall, we were interested in examining how SPAN and math ability contributed to variation in parent and child talk during play. And we found that variability, that there was wide variability in the math talk that parents and children used during play. While we predicted that SPAN would relate to differences in math talk, we found that it did not predict use of math talk, but it did relate to math ability for parents and for children. And And we also found that math ability related to math talk, with child math ability relating to talk about contextual use of numbers, and parent math ability relating to talk about advanced math concepts. And overall, these findings provide further evidence that parent and child cognitive factors relate to children's math experiences and engagement in math. And they also indicate that further research is needed to examine additional factors that contribute to variation in parent-child math talk during play and informal learning activities. So finally, I'd like to thank members of the Early Childhood Interaction Lab, as well as the children and parents who participated in the study. I think if anyone has questions while Marjorie is getting her talk set up.
Okay, then I'll get started then. Thank you so much, Mary. It was really interesting. I'm really glad I got to hear about that. I want to thank everybody for coming. I know, at least for me, this period of time has been really isolating, especially in terms of getting to talk to other people about my research. And so I'm really excited to talk about that. And so that said, I also want to apologize that I've slightly altered my talk to talk about what I'm most interested in right now, because that's kind of where I would love to talk a little bit more with all of you and to receive a little bit of feedback. Don't worry, it still fits in this symposium. So I'm going to talk a little bit about the role of parents and teachers' math anxiety on children's math achievement. So one factor that can negatively influence children's math achievement is math anxiety. And math anxiety is often defined as fear and apprehension that many people experience when engaging in math. I want to argue that we can see the impact of math anxiety throughout our culture, right? So in newspaper headlines like "We hate math, says 4 in 10 a majority of Americans," or in one of Barbie's first talking phases, "Math class is tough," or in this shirt from 2015 from American Apparel, "Allergic to algebra." But math anxiety is also not a new phenomenon, right? And so this is one of my favorite quotes, poems, I don't know if they quotes, poems, and this actually comes from an Elizabethan manuscript from 1570. And importantly, math anxiety is not a proxy just for poor math ability. Rather, math anxiety is thought to cause negative thoughts and ruminations that can co-opt working memory resources that are needed for success in math tasks. And math anxiety is also not a US phenomenon, it is an international phenomenon. So even if we think about the United States having a unique education system, we still see the problem of math anxiety throughout the world. So this graph shows the mean index of math anxiety on the x-axis and the mean mathematics scores on the TIMSS, the International Assessment, on the y-axis. Right? So we see this overall trend line across countries. Researchers often think about the factors that influence an individual's own math anxiety. For example, the cognitive worry and physical arousal of math anxiety can decrease working memory resources, leading to lower math performance and maybe avoidance of the domain. So many researchers think about this recursive cycle. And I think that's really important, but I also am really interested in also thinking about how socializers like parents and teachers could also negatively impact children's math learning. So I think by adding these important figures in children's lives, we can get a fuller understanding of the impact of math anxiety. And so the first study I want to talk about is, does elementary school teachers' math anxiety relate to children's math learning over the course of first grade? In this first study, we worked to replicate the previous study from other colleagues, finding the relationship between teachers' math anxiety and girls' math achievement. Given the important theoretical and policy implications of the finding, we thought it was important to replicate this study using a much larger sample. So in this study, we recruited 551 children. A little under half of them were identified as female, and 40 first grade teachers. And in the fall of first grade, students created a pretest using the Woodcock-Johnson applied problems math subtest. And so this gives students verbally presented word problems. So this is an example. So if you have 7 pennies and you spent 3, how many pennies would you have left? In the winter, teachers completed measures of their math anxiety using the SMARS, the Short Math Anxiety Rating Scale. And so this would ask questions like, how much anxiety would you feel while calculating a tip at a restaurant? From some anxiety to extreme anxiety. Teachers also completed measures of their content knowledge for teaching mathematics, which is also called the CKTM. In the spring, students completed the other version of the Woodcock-Johnson 3, so Form B instead of Form A. And so these also gave verbally presented word problems. And so what I'm going to show you here is a median split of low and high math anxious teachers, right? So I run the analyses continuously, but I think for depiction, it's nice to see things dichotomized. And on the y-axis, we have this spring math performance. And so what we find is that children who are in a higher math anxious teacher's classroom learn significantly less math over the course of first grade compared to children in a lower math anxious teacher's classroom. And so previous research had suggested that this finding applied specifically for girls. And so with our larger sample, we wanted to look at this gender effect. And so what we actually find was a little bit surprising to us, right? So we basically see for both this impact of high math anxious teachers for both boys and for girls. So impacting both genders. It visually looks like and numerically is larger for girls, but it's not statistically different between boys and girls here. And so I was interested to see if we saw the same relation between parents' math anxiety and children's math learning. Since we see this negative relation between teachers' math anxiety and children's math learning over the course of first grade, I was really interested in looking at parents. Most children have their elementary school teacher for a year, maybe 2 in some systems, but children hopefully have their parents for their whole lifetime. And so the potential importance of a high math anxious parent might be particularly strong. And so in this second study, we recruited 587 children, first grade children and their parents, and we're going to follow them over 3 years. And so we're going to assess children's math knowledge very similarly to in the previous study, using the Woodcock-Johnson 3, the applied problem subtest. Again, so there are these verbally presented problems that students completed working one-on-one with a trained experimenter. Okay. And parents completed the math anxiety rating scale. So this 25-item mathematics anxiety scale, right? Again, asking them to rate their anxiety they feel in everyday situations using math. So we continue to follow these children, testing their math performance in the fall and spring of first through third grade. And so here I'm going to show on the y-axis this math performance in the Woodcock-Johnson. And so what we find, I'm not sure why you don't see the label, but you can believe me. In our darker blue bar here, we see the children of lower math anxious families, and in the light blue bar here, we're going to see the children of a higher math anxious family. And so in the fall of first grade, we see no differences in math performance between children of high and low math anxious families. But we see this gap start to emerge. The children of low math anxious families are outperforming high math anxious families by the end of first grade. And we see this same trend throughout the fall of second grade and the spring of second grade. And in fact, when we look out to third grade, we still see this as well, right? So we see that still children who of a highly math anxious family are performing worse compared to a child of a low math anxious family. So what happens when children have both a highly math anxious parent and teacher? Given the prevalence of math anxiety in the elementary school teaching population and in the general population, it's very likely that children have both a highly math anxious parent and a teacher. So one possibility is that having a strong math teacher or a non-anxious parent could inoculate children against the effect of math anxiety. So we use a similar method as in the previous studies, measuring math anxiety using the SMARS and children's math learning using the Woodcock-Johnson. And so here I'm going to show us thinking about parents, right, who we've been talking about most recently, thinking about for a low math anxious parent, what impact does having a high math anxious teacher, right? And we see this overall effect that even if your parents are low math anxious, having a high math anxious teacher is related to lower math learning over the course of the year. And then when we look at a high math anxious teacher, we still see this effect as well, right? So for a child who's of a high math anxious parent, we still see an impact of having a high math anxious teacher, right? So statistically, these are two main effects, right? There is not an interaction between the two, which is, I think, both tragic, right? I was hoping that maybe there'd be inoculation effect. Having a really strong parent or teacher could be preventative, but also by not having this interaction, it's not uniquely worse, right? Something else doesn't happen. And so currently I'm building on this work to see if we can see these same effects from short-term parent-child interactions. How we've been doing this is by having families come into the lab and randomly assigning high and low math anxious families to complete a typical first grade math homework assignment. And some families do so under pressure, right? We tell them that it's really important how their child does. We tell them that we're going to provide feedback. And other families are told to have fun and not to worry about completing the whole task. So I'm going to show you a brief video right now to give you a sense of what these interactions look like.
62. I have to do it with 50 and 50. That equals 100. Now we're down to the 10 and 20. That equals 130 cents.
Well, it's going to be 10. So 60 minus 50 is 10. And then 75 minus 50 is 25. So it would be 10 plus 25 is?
How much popsicles?
What's 10 plus 25?
10 plus 25 equals.
Okay, so let's just give you an example of what these look like. So we're still in the process of coding these data, but I'm particularly interested in thinking about what are families doing in these interactions. One of my surprising things I've seen is who's holding the pencil, right? Who decides that they should hold the pen and when does that go back and forth? And so this is a short presentation, but I'm hoping I've argued that math is important. And I think to this audience, we all believe that and mathematical well-being is more than just this math achievement. These attitudes matter as well. And that parents and teachers' math anxiety are related to this lower achievement for students. So I'm really excited to explore the relationship between parents' attitudes and children in these short-term interactions. Thank you so much. I want to thank all the collaborators that I've worked with and the participating children and families. Thank you so much. Does anyone have any questions as we transition?
I actually have a question, if it's okay.
Yeah.
I was curious if you collect any math performance measures from your teachers or your parents. I know it's sort of challenging in teasing apart the math, experience and performance from the attitudes, but I'm curious of whether the teachers, even if you measure things like what they studied in school, like if you have any questionnaires about that, whether you can control for things like that to increase the specificity of the attitudes association.
That's a great question. So with the teacher study, we do measure their content knowledge for teaching mathematics. And that does have a level of math performance related. So it's asking if a child gives this correct answer, what does this tell them about their misunderstanding about decimals, right? So I guess we could debate whether that is exactly what you're asking, but we use that, and when we control for that, it doesn't change the effects we see.
Yeah, that's exactly what I was asking. I was curious if you control for it, whether the effects still remain.
Yep. So
And
they do.
yeah, your experimental work is really cool. I like your current directions.
Thank you. With parents, we've tried to measure math performance, and it's really hard to get them to do that. Yeah, so we've had less success with that, but it's a great question. Thank you.
Okay, can people hear me?
Yes.
Okay. Yes, good. Thank you. Sorry, I was having a bit of a problem here. Okay, right, well, thank you, Marjorie, for your interesting talk. It's quite interesting because it covers some of the same areas as my talk, so it's quite interesting to see the similarities and differences between the two. Okay, so I'm going to talk to you today about how attainment is affected by maths attitudes in primary school children, their teachers, and their caregivers. Maybe. So children's numeracy in Scotland continues to fall, with children from disadvantaged backgrounds most affected, contributing to the academic attainment gap between those from richest and poorest homes. Previous research demonstrates poor numeracy skills lead to high unemployment, low income, and poor health, and fail to prepare our young people for demands of life in the 21st century. Previous research tends to focus on affluent areas where academic outcomes are highest, rather than disadvantaged areas where numeracy problems are greatest. Most considers older children and compares performance of different groups rather than longitudinally. And in addition to individual differences in cognitive abilities, other factors such as attitudes to maths are argued to play a role in attainment. So why do some children struggle? Although individual differences affect children's maths performance, research shows emotional factors and attitudes also affect attainment. So how is maths attainment affected by attitudes? And which attitudes are we talking about here? In this study, we're considering how maths anxiety, mindset, and transmission of attitudes from significant adults to children are related to children's maths attainment. So first of all, maths anxiety. What is maths anxiety? Maths anxiety is an extreme physiological and emotional response that sufferers experience doing or thinking about maths. As maths anxiety is worse in older than younger children and is linked to attainment, it's important to understand maths anxiety from a young age. Another factor that we're considering is mindset. So what do we mean by mindset? Growth or fixed mindset describes an individual's beliefs about intelligence that are argued to affect people's performance in many scenarios. Those with a fixed mindset believe intelligence is fixed and unchangeable, so perseverance is pointless, whereas those with a growth mindset believe intelligence and attainment improves with effort in teaching. Research argues these people can achieve their full potential through hard work. They just haven't got there yet. And research also suggests that children with a fixed mindset have lower academic attainment than their growth mindset peers. The third factor to consider is carers and teachers' attitudes to maths. Research has found teachers and parents' attitudes to maths can predict children's maths attainment. Therefore, if parents believe maths is hard or they can't do it, their children may believe that they can't do it either. If teachers believe some children just can't do maths, children can believe this too. And if teachers are anxious about maths, it can be associated with children's maths anxiety and attainment. So the literature shows maths anxiety, mindset, and transmission of attitudes may be related to children's performance on maths and arithmetic, and this area is little researched in children as young as those starting year 1 in Scottish schools at 4.5 to 5 years old. The first aim of the current project was to investigate if children's maths anxiety and growth mindset attitudes were related to their performance on numeracy and problem-solving tasks. And secondly, we wish to investigate the relationship between teacher and carer attitudes and with children's attitudes and children's attainment. So this study is part of a cohort sequential longitudinal project examining children's developing attitudes and their maths-related attainment during the first 3 years of formal schooling. During this time, the children complete a battery of tasks related to maths. However, the current study discusses the first experiment in the project and is focused on how attitudes of children, teachers, and carers may be related to children's attitudes and to numeracy and problem-solving skills in their first year of school. So participants were recruited from 4 local authority primary schools in the Dundee area of North East Scotland at the beginning of the children's year 1. 190 girls and 180 boys participated in the study. 75% of participants were from schools in areas of extreme deprivation, and the remainder came from schools within the least deprived 15% of the Scottish population. 20 female teachers and 169 female and 66 male carers participated in the study. Children completed the Child Maths Anxiety Questionnaire and the Implicit Theories of Intelligence Scale, presented together to class groups as one PowerPoint quiz with a paper response sheet, and I will show you some examples on the next slide. The quiz was conducted within the first 2 months of formal schooling. Children then individually completed the Wyatt standardised tests of numeracy and problem solving 3 months after the questionnaire. The numeracy task is an untimed progressive paper and pencil based task which assesses basic number skills and basic operations with integers. The problem solving task is also untimed and assesses basic number concepts, everyday applications, geometry and algebra, and the participant provides oral and pointing responses for this. Adults completed the Mathematics Anxiety Rating Scale and the Growth Mindset Questionnaire, combined into one paper-based questionnaire. Carers completed this at school parent-teacher contact events, and teachers completed it in school. So here is an example of a maths anxiety question. So the focus of the maths anxiety questions is on how each scenario makes children feel. So they're instructed there's no maths involved. All the experimenter wants to know is how they feel about each presented scenario. Options are really happy, just okay, or a bit sad or worried, and then children must circle whichever option is appropriate for them. And here's an example of a growth mindset question that the children would see, and again they would circle the appropriate shape which corresponded with their answer. Okay, so now on to the results for maths anxiety. First, we'll look at children's maths anxiety. So figure 1 shows numeracy scores on the y-axis and maths anxiety levels on the x-axis for high SES children in red and low SES children in blue. So we can see children with high maths anxiety on the right here scored significantly less than those with average or low maths anxiety. And children from low SES backgrounds scored significantly lower than high SES children for all levels of maths anxiety. So in the current study, high maths anxiety was associated with low numeracy skills. Figure 2 shows problem-solving scores on the y-axis and maths anxiety levels on the x-axis. And again, we can see children with high maths anxiety here scored less than other children, although this time the difference was not significant. Again, though, children from low SES families in the blue scored significantly less than high SES children for all levels of maths anxiety. So again, maths anxiety, high maths anxiety was associated with lower attainment. So next we're going to look at children's mindset. So figure 3 shows a significant positive relationship between maths anxiety score for children and mindset score. As maths anxiety increased, children were more likely to have a growth mindset, which is not what the growth mindset literature would predict. Figure 4 shows mindset and numeracy, and figure 5 shows mindset score and problem solving score. And we can see that mindset had no relationship with either numeracy or problem solving. So next we will consider teachers' attitudes. Figure 6 we can see a positive relationship between teachers' maths anxiety and children's maths anxiety. So as teachers' maths anxiety increases, so does children's maths anxiety. And figure 7 shows that the relationship between teacher maths anxiety and children's numeracy in year 1. So as teachers' maths anxiety decreased here, children's numeracy score increased. And figure 8 shows a similar pattern for problem solving, although the relationship this time was not significant. So I'm not going to waste time with a series of plots about teacher mindset. Suffice to say, there was no relationship between teacher mindset and child mindset, year 1 numeracy, or year 1 problem solving score. So now we'll look at parents and carers' attitudes. Figure 9 shows no relationship between carers' maths anxiety and children's maths anxiety overall. However, if we look at figure 10, where family SES is considered, we find a negative relationship between maths anxiety of high SES carers and children, which is shown in the red here, such that as maths anxiety of carers increases, maths anxiety of children decreases. For low SES families shown in the blue, as carer maths anxiety increases, child maths anxiety also increases, although the relationship was not significant. Figure 11 shows children's numeracy and carers' maths anxiety. So as carers' maths anxiety increases, children's numeracy scores decrease for high SES in the red and low SES in the blue, children from high SES and low SES families. And figure 12 shows a similar pattern with carers' maths anxiety related to problem solving for high in the red and low in the blue SES children. Now, looking at carers' mindset in figure 13, we can see there was no relationship between mindset of children and their carers. However, figure 14 shows a negative relationship between carer mindset and numeracy score, such that low mindset on the y-axis here represents fixed mindset. So we can see that higher numeracy scores were associated with fixed mindset, which is not what the literature would predict. And a similar pattern is seen in figure 15 for carer mindset and problem solving, although this is not a significant relationship. So now moving on to the discussion. Participants were 2 consecutive year 1 cohorts. They were 4 or 5 years old, and 28% of the participants reported high maths anxiety in the first weeks of year 1, and 58% of them had some feelings of worry and anxiety associated with number. Considering these children had been in school for only a few weeks and therefore had little exposure to formal maths teaching, this is concerning. Presence of maths anxiety in such young children is a novel finding and adds to the published literature. Children with high maths anxiety had lower numeracy scores and problem-solving scores in year 1, and children from low SES families had lower scores than high SES children for all maths anxiety levels. The Scottish education system has saturated schools with growth mindset interventions over the past 5 years, and Dundee is involved in a large growth mindset project. However, in the current study, there was no relationship or no beneficial relationship between mindset and attainment. Given the investment in growth mindset interventions and the results seen here, it could be argued that resources would be better directed towards tackling maths anxiety than mindset. Thinking now about the transfer of attitudes from adults. Teachers' maths anxiety was associated with children's maths anxiety and children's numeracy. As teacher maths anxiety increased, children's maths anxiety increased and numeracy scores fell. However, teachers' mindsets were not related to children's mindset or to children's attainment. There was an interesting relationship between carers' maths anxiety and children's maths anxiety. As high SES carers' maths anxiety increased, child maths anxiety decreased. But as low SES carers' maths anxiety increased, child maths anxiety also increased. It could be that high SES carers were more aware of their own maths anxiety than low SES carers, and so wanted to avoid influencing their child's attitudes to maths. Carer maths anxiety was related to numeracy and problem-solving scores. As carer maths anxiety increased, children's attainment decreased. This relationship was strongest for children from low SES backgrounds whose attainment was already lower. There was no relationship between carers and children's mindset, although mindset and problem-solving scores were related. This was not in the expected direction, as growth mindset attitudes were associated with lower problem-solving attainment. Results from the first experiment in this longitudinal study suggest children's maths anxiety, but not mindset, is related to their attainment, and teachers' and carers' maths anxiety is associated with children's maths anxiety and attainment. However, neither children's nor adults' growth mindset seems to have the positive influence on attainment that much of the growth mindset research would predict. A limitation of the study is the number of participating carers. Although parents and carers agreed to children's participation, carer participation varied between schools, from 80% in one school to only 25% in the fourth school. Therefore, we do not have the data available to evaluate the relationship between all children and their carers. The highest attaining children in all schools were most likely to have parents attend school events and therefore complete the adult questionnaire. This may impact the findings regarding the relationship between carer attitudes and performance of the lowest attainers. However, even with the numbers that we had, we found a significant negative relationship between carers' maths anxiety and children's numeracy and problem-solving attainment. In conclusion, the current study adds to existing work by identifying the presence of maths anxiety in children from 4 years old. It demonstrates an association between adults and children's maths anxiety attitudes and early maths attainment, but shows no such link with growth mindset attitudes. The results so far suggest investing in maths anxiety prevention strategies rather than growth mindset strategies for children and teachers in the early years could be beneficial. As the current study is the first part of a 3-year-long longitudinal study, more evidence regarding the influence of early maths anxiety on children's maths attainment will emerge in due course. I'd finally like to thank the children, families and schools who participated in the study. Okay, does anybody have any questions?
Hi, Dawn. I have a quick question. This is Joanne Lefebvre. Nice to see you.
Hi.
Do you think that it would make more sense to try and remediate the math anxiety of teachers, or to work on the actual math knowledge and specifically pedagogical math knowledge of teachers in the long run? Which do you think would have a bigger impact?
Yeah, that's a good question. I think it's very obvious that some of the teachers are very maths anxious, but I also think it's maybe having a higher level, a higher minimum level of maths education for early years teachers might be beneficial. I mean, I definitely witnessed some teachers saying, "Oh, take Joe, he's good at maths. Take Maisie because she's rubbish at maths anyway, and she's not going to miss anything anyway because she's not going to get it." So you're getting all these kinds of messages from the teachers from the early earliest of stages, and teachers even saying to the children, well, I'm not any good at maths, so it doesn't matter if you struggle. You know, I managed to be a teacher even though I'm no good at maths. So I think both of these aspects actually need to be tackled.
Okay, thank you.
Makes you curious about some kind of Pygmalion effect for math specifically, if we just randomly assign children to be, we tell teachers that different kids are good at math versus not. Anyway, we have not much time left, so we're going to jump into this last conversation. If there are any other questions for any of the presenters, feel free to put them in the chat. I won't be offended if you're chatting away while I'm presenting. So I am presenting today briefly a study looking at exploring effects of an early math intervention, and specifically the importance of parent-child interaction. So to briefly breeze through some introductory background information, we know from all of MCLS and decades of work that there is substantial stability in early math skills, and early individual differences in math skills portend later skills in math, in reading, in labor market outcomes, in all kinds of things. But there are a lot of different influences on the development of early math skills. So there's evidence for intergenerational transmission of math. Parents who have higher levels of math skills tend to have children who have higher levels of math skills. And that's true both for kind of domain-specific math abilities like acuity of the approximate number system, and math achievement more broadly, as shown by kind of behavioral genetics work. We also know that there are a number of environmental factors, including what's been termed as the home numeracy environment, which includes the frequency with which parents engage in math with their kids, is associated with the development of math skills. So Geetha Ramani is here. One of her earlier studies found that children who were assigned to, or parents and children who were assigned to a math game versus a color game, which here was just printing numbers on, or digits on a board game, improved children's mathematical skills over the course of the intervention. And we know that there's some preliminary evidence to suggest that there are effective at-home interventions to improve children's mathematical skills. Children and families who are randomized to conditions where they're told to play more math games, or given math games, improve their mathematical skills over time. So we were interested in these multivariate influences on the development of children's math skills. So we were wondering, does training parent math skills or providing opportunities for parent-child interaction around numbers affect children's math skills? And if so, what is the mechanism by which these occur? So to do that, we recruited, I'm going to just talk about the analytic sample of 136 parents and children who were seen when children were 46 months, so just before age 4, 48 months, and then again at 50 months and 52 months. But after the 48-month period, families and parents and children were assigned to one of 5 conditions, one being a number board game, one being a color board game, a parent math training, or a parent approximate number system acuity training, a parent trivia game, and a no training control. So both these parent knowledge or the parent trivia game and the no training control were both control conditions. The parent knowledge one was an active control condition, and I'll show examples of these on the next slide. But I just wanted to talk about, we then had an immediate post-test, which parents and children were asked to play these games twice a week for this 2-month period. And then 2 months later, we brought kids in and did a delayed post-test. So what do these different conditions look like? We had a parent-child math game, very similar to the number race. Parents and children were given this board with a spinner. They spun the spinner and then moved the number of spaces that were specified by where the spinner landed. Similarly, we had the same game, but as a color game. So if they landed on red, they would move to the next red square or box. It's not a square, rectangle. Parallel. We're going to call it a quadrilateral. Nope. Okay, well, it's a shape. Then we had 2 parent-only training conditions. One was a approximate number system training condition. This was an approximate arithmetic training. So they saw 2 sets of dots go behind this occluder on the top, and then had to pick the approximate value that was closer to the total value of what was behind the occluder. And then finally, we had a parent-only active control condition, which was this trivia training condition. It was just random facts that parents were asked to answer. If anyone is curious about this Dingo Ate My Baby thing, there's a great episode of You're Wrong About, a podcast about it, but that is not the subject of this particular talk. So at each of the 4 lab visits, we had children complete the TEMA, the Test of Early Mathematical Ability, which is a standardized assessment of children's early number skills, which includes calculation, number comparison, Arabic numeral literacy, and understanding of numerical concepts. And we also had parents complete a math activities questionnaire, which was a frequency of engagement with different math and numeracy activities over the recent period. In all of the analyses I'm going to show, we control also for child age, child vocabulary, child sex, whether or not the parent had received a bachelor's degree, and these analyses are robust to a number of different covariates that I'm happy to talk about, including things like math attitudes and math anxiety. So first we wanted to see, did parents actually do the trainings that they were assigned? They were supposed to have done them up to 16 times, that's twice a week, for 8 weeks, the 2-month period. And we see that on average, they did. There was a little bit of spillover where we had parents assigned to the wrong condition. So we do have something like an average of 0.5 sessions for parents who were assigned to no training conditions. But we did have no significant differences among the 4 different training conditions where they were actually supposed to engage in training. So no one or very few parents did the full 16, but also most parents didn't do 0. So then we were interested in, does this actually have an effect for children's math skills? So this is what I'm presenting on the y-axis here is the difference in raw score on the TEMA from visit 4 versus visit 1. This is also robust to visit 4 versus visit 2, which is what was when the training was assigned and the post-training follow-up. And so we see on the no training control conditions, so children who were not doing any kind of lab assigned training, they improved about 8 points on the TEMA on the raw score. Parents and children who were assigned to the math game, about 8 points. Parents and children who were assigned to the color game, about 7 points, not statistically different from 8 points. Parents on the math game, again, the kind of theoretical mechanism here was if we improve parents' math skills, then it will in turn improve children's math skills. We see actually a significantly lower raw difference in children's TEMA scores where they improve only about 4 points. So that's less actually than the no training control condition. And parents who receive the trivia training, again, not statistically different from this 4-point gain and statistically different from each of these 3 other training or no training control conditions. So both of the parent training conditions actually resulted in children doing worse than if they'd been given no training whatsoever. So looking at this change over time, this is the 4 visits, again, 2 months apart, and the TEMA raw score presented on the y-axis. So here the training condition was assigned at visit 2, and we see that as children leave this training condition or the training condition assignment, we start to see a widening of gaps between the training conditions on children's TIMA scores, but those don't really become statistically significant until we reach visit 4, when we start to see a real kind of extension of the patterns that we see starting to emerge by visit 3. And so the question is, why is that? They're not doing the training anymore. Is it that we don't see that the no training control condition, which is this dark blue, royal blue, purple line, isn't just rocketing upward? So we wanted to see kind of what could be continuing through the training condition, or through the time period after training had ceased. So one thing that we've talked about and thought about is differences in parents' engagement with the home numeracy environment. Because although we gave parents and children specific games to play, we also asked them at regular intervals to fill out a home numeracy questionnaire. And so again, this is where training conditions were assigned, and this is where the training was taken away, where they returned it to the lab. And we see a subtle but significant increase in the amount of math activities parents report doing with their children over time, suggesting that it could be that parents who receive regular questionnaires about how often they're participating in numeracy activities with their kids might just start to do more numeracy activities. So we wanted to see whether this mediated the relation between the lower level of performance from children in the parent training conditions and children in the parent-child or no training condition. So again, compared to a no training control condition, children of parents in the parent math condition improved on average almost 4 points less in gain over time. And we see that might be in part because we see that parents who are in the parent math condition are increasing the number of math activities they're doing to a slightly lesser extent than those in the no training control condition, which does have an effect on the change in TIMA score. So we see a small, statistically significant, but not complete mediation effect, whereby the training condition affects TIMA score through change in math activities. So to conclude, because I know we are running over time, parents of children in the parent-child interaction and no training control conditions generally outperformed those who had parents in the parent training conditions, and effects were partially mediated by changes in the home math environment, where parents in the no training control condition reported a greater increase in math activities than did those in the parent math training condition and the parent trivia condition. So it's possible that, or the way that I'm thinking about it is that these iatrogenic effects, the effects where we see less of an increase from randomization to a training condition, might be a result of taking away important time for parent-child interaction, because we were asking parents to do these games twice a week for 10 minutes each. And so it's important for future work to consider the already overwhelming demands of parents of young children. If we're asking them to do something, what are they taking away? What are they not doing in its place? So with that, I would love to thank all the parents and children enrolled in the study, and my lab who really did all the data collection, and I just jumped on at the end, and thanks to all of you. So I realize it is just after our time to sign off, but I'm happy to take questions, and I think all of us would be happy to stick around for a couple minutes.